The basics of grounding. Grounding is electrical contact with the earth. A ground is a conducted path between electrical equipment and the earth. If you are standing on wet earth or a wet concrete floor that adjoins the earth and you contact voltage, you can become grounded. An electrical current will pass through you, giving you an electrical shock, possibly severe enough to kill you. However, if your home's electrical system, from the service panel through the branch circuits, is properly grounded, it greatly lessens the chance of shock. One advantage of having a properly grounded neutral conductor in the house is that the voltage to ground will not exceed approximately 120 volts. Typically, voltage to ground in the electrical distribution system ranges from 2400 to 8000 volts. The transformer that reduces these high voltages to the 120 volts used in a house has a high voltage side and a secondary 120 volt side. Electric power for a home comes from the secondary side. For absolute safety, the distribution system connects the grounded conductor on the high voltage side of the transformer to the grounded conductor on the 120 volt side. So long as this connection is sound and grounded, an accidental ground on the high voltage feeding the transformer will create a fault that will trip a circuit breaker or open a fuse or otherwise turn off the high voltage and of course the 120 volts feeding the house. However, if the common connection were still in place but the grounding conductor were eliminated, there could be trouble if an accidental ground occurred in the high voltage supplying the transformer. Although the actual result would depend on the primary voltage involved, theoretically the voltage to ground in your house could exceed 8000 volts. To further assure proper grounding, all house receptacles, in addition to being connected to a hot wire, most often black or red, and to a neutral wire, white or grayish white, must be connected to a ground wire, always bare copper or green, that joins to a grounded connection in the service panel. This connection is made either through a grounding conductor in the cable feeding the receptacle or through the sheathing of metal-jacketed cable or metallic conduit used in the system. A washing machine serves to demonstrate how this grounding inside the house protects you. When the machine is plugged in and turned on, only the hot and neutral wires to which the washer is connected normally carry current. The machine and its drive motor are constructed in such a way that their wiring is insulated or physically isolated from the machine's metal frame. For further protection, the washer's frame also connected to ground through the green wire in its cord and the U-shaped prong in its plug. However, if excess heat or some other cause breaks down the drive motor's insulation, its frame and the washer's frame will become energized when the machine is turned on. If the electrical system in the home is properly grounded, the high current flowing through the motor to ground will open the circuit breaker or fuse protecting the circuit supplying power to the washer, and no damage will occur. However, if the grounding prong in the plug is missing or the receptacle isn't properly grounded and you happen to touch the machine and the properly grounded clothes dryer next to it at the same time, the fault current will flow from the washer through you to ground and a fatality could occur. Electricity in the home. From the transformer, the power company brings electricity into a home via overhead wires or underground cables. Underground service is aesthetically less intrusive, but there is no difference in the quality or safety of the electrical service you receive. Homes built after 1940 and pre-1940 homes that have had their electrical service modernized will have three-wire service. This means there are three wires called service entrance conductors connected to the service entrance equipment of the home. Two of these wires are hot, carrying current. The third one is the neutral conductor. The three-wire system provides a home with both 120 volt and 240 volt. The neutral wire and either hot wire combine to supply 120 volts for such items as lamps, radios, food processors, and wall receptacles. When 240 volt service is necessary to operate a major appliance such as a range or clothes dryer, for example, both hot wires combine with the neutral wire to supply the required electricity. However, note that water heaters and large air conditioners also require 240 volts, but they are connected only to hot wires. They don't have clocks, timers, lights, or other appurtenances that require 120 volts for their operation. Older, unmodernized homes usually have two-wire service and as few as two fuses. This means they have one hot wire and one neutral wire supplying only 120 volts. This service is wholly inadequate by modern standards, especially if the home is equipped with many large appliances.